timeless concepts from Physics Helpline. In this video tutorial, we will discuss a multiple choice question with one or more correct options taken from JEE Advanced Physics question paper of 2023. The question is based on motion under gravity on a curved surface, after which the ball falls on the ground and rebounds. The ground offers a coefficient of restitution. Read the question carefully. A slide with a frictionless curved surface which becomes horizontal at its lower end is fixed on the terrace of a building of height 3h from the ground, as shown in the figure. A spherical ball of mass m is released on the slide from rest at a height h from the top of the terrace. The ball leaves the slide with a velocity vector u0 is equal to u0 x cap and falls on the ground at a distance d from the building, making an angle theta with the horizontal. It bounces off with a velocity v and reaches a maximum height h1. The acceleration due to gravity is g and the coefficient of restitution of the ground is 1 by root 3. Which of the following statements are correct? The options are given in the question. We are required to find the correct options. Now for the solution. We have named the crucial points as A, B and C. Let us first consider motion from A to B. It is given that the ball leaves the slide with a velocity u0 is equal to u0 x cap. That means it is in the horizontal direction towards right at B. So speed of the ball is equal to u0, therefore kinetic energy at B will be equal to half m u0 square because m is the mass of the ball. So which should be equal to the loss in potential energy from A to B, that is your mgh. M is the mass of the ball, g is the acceleration due to gravity and h is the fall in height from A to B, which gives u0 is equal to root over 2gh because m and m gets cancelled from both sides and u0 square is equal to 2gh, therefore u0 is equal to root over 2gh. Therefore we get vector u0 is equal to u0 x cap, which is equal to root over 2gh into x cap, which therefore the option A is correct. So let us mark it because we have to remove all this and again work for the other part. Now let us consider motion of the ball from B to C. It's totally in the air. Therefore we have got the horizontal velocity is constant. It's going to remain constant because there is no acceleration in that horizontal direction. Therefore we can write Vx, x component. Vx is equal to u0 is equal to root over 2gh. Now vertical displacement from B to C of the ball, that is through vertical displacement of 3h, that is it comes down by 3h from as it moves from B to C. Therefore vertically downward velocity at C is given by Vz is equal to root over 2 into g into the height, fall in height, that is 3h, that is equal to root over 6gh. Therefore we can calculate tan theta is equal to Vz by Vx. Vz by Vx. Vz by Vx is equal to root over 6gh divided by root over 2gh, which is equal to root 3. Therefore we get theta is equal to 60 degrees. Therefore we get option C is correct. Option C is correct. Let's mark it here. C is also correct. A and C correct. After bouncing at C, then we have got this component of velocity in the x direction, which remains constant at u0 is equal to root over 2gh. Therefore, we can write vx is equal to root over 2gh. The downward velocity with which the ball hits the ground at point C is given by vz downward is equal to root over 6gh, that we have already calculated. After the rebound at C, we get the upward velocity as, let us denote it as vz dash, which is equal to ebz, where e is the coefficient of restitution, which is given as 1 by root 3 into root over 6gh, which is equal to root over 2gh, which gives v is equal to root over 2gh, the x component, horizontal component, and root over 2gh z cap, that is your vertically upward component, which gives v is equal to 2gh, root over 2gh into x cap plus z cap. Therefore, we get the option B is not correct. So, this is not correct. So, we have got only A, B is not correct, C is correct, and let's examine D. So, after rebound at C, the upward velocity is given by EVZ is equal to root over 2gh, that we have already calculated. Therefore, the height attained by the ball after rebound at C is given by h1, is given in the question. h1 is equal to EBZ whole square divided by 2g. Now, EBZ is equal to root over 2gh whole square will give us 2gh by 2g, which is equal to h. Therefore, h1 is equal to h. We'll keep this here and remove everything else. Now again, let us consider the motion of the ball from B to C. Now vertically downward displacement from B to C is s downward is equal to 3h, and acceleration due to gravity is equal to g. Therefore, time t is given by, during the fall, time t is given by root over 2s by g, putting the value of s is equal to 3h. So 2 into 3h, that is 6h by g, root over 6h by g. Now we'll try to find the horizontal distance covered during this motion from B to C, that is the value of d. Now d is equal to bx, x component of velocity is horizontal velocity, into time. This is your root over 2gh into time is equal to root over 6h by g. Now g gets cancelled. This is equal to root over 6 to 12h square is equal to 2 root 3h, which implies d by h is equal to 2 root 3. We have already established that h is equal to h1. Therefore, we can write d by, this implies d by h1 is equal to 2 root 3. Therefore, option D is correct. D is also correct. So, therefore, the correct options are A, C and D. This completes the answer to the question. Thanks for watching.